Hello, AP Physics 1 students. This is Ms. Dunlap, and this is our first video, the first video I have ever made for a flipped classroom. I'm pretty excited. And here we go. These are mostly vocab notes on distance versus displacement, as well as speed versus velocity. Our learning target is I will distinguish between distance, displacement, speed, and velocity. First thing we got to talk about scalars and vectors. Now, some of you have taken pre-calc, so you know what a vector is. Maybe scalar is a new word. We're just going to go over it. We will learn more about this in class. Don't worry too much about it. The main thing is that vectors have direction. So anything we can measure is either a scalar or a vector. And scalars are things that we measure that have no direction. It's just a single number that gives the size or magnitude. We represent scalars with non-bolded variables and variables that do not have an arrow over them. So for instance, our scalar quantities are volume, temperature, mass, and now distance and speed. Volume, never going to have a direction. Represented by capital V, not bolded, no arrow over it. Vectors, on the other hand, are quantities which deal with both magnitude and direction. So anything that's important to know what direction, that's a vector. We represent it by an arrow that gives the direction with a length proportional to the magnitude of the quantity. So vectors that are bigger, so for instance, 2 meters per second to the west is going to be twice as long as a vector that's 1 meter per second to the west. They're both going to point west. And when we write them as either bolded variables or variables with an arrow over them. I prefer to use variables with an arrow over them just because when you handwrite, it's easier to draw an arrow than to make it bold. And then if it's got an arrow over it, you know it's a vector because vectors are arrows. So in kinematics, that's the study of the motion of an object, not worrying about forces at this point, just where it is, where it's going. We have two scalar quantities. We have distance and speed, and we have three vector quantities that also have a direction: displacement, velocity, and acceleration. Now, acceleration we're not going to get to for a little bit. We're just dealing with displacement, velocity, distance, and speed for now. Then we'll get to the acceleration part, and that's where things get interesting. So, distance and displacement. First thing we're going to talk about, position. It's not exactly one of our vocab words because it's a pretty easy one. It's just where the object is located. And we represent position with X. Plain old X, no arrow over it, it's not bolded, it's just X. So if we say X equals 2 meters, that just means the object is 2 meters away from whatever we're calling 0. We'll get more into defining the frame of reference later. Now let's talk about displacement. Displacement is how far an object is from where it started. And it is completely path independent. It doesn't matter how the object got to where it is. It only matters where it started and where it ended up. And we draw an arrow that starts where it started and ends where it ends up. And the variable for this is delta x with an arrow over it. Remember, delta is the change in, and it means final minus initial. So the displacement of an object is equal to its final position minus its initial position. So if you look over here, we've got x sub 0. That is read x naught. And naught is N-A-U-G-H-T. It's the British word for 0. So, you know, some fun trivia. In England, tic-tac-toe is called noughts and crosses. Noughts for zeros, crosses for x's. A little bit of trivia. So this guy right here is x sub f, because it's a subscript, minus x naught. This can also be called x sub I for initial position. I like x naught, it's more fun to say. Now for distance, distance cares about the path. Distance is the length of the path an object follows. It depends on the path the object takes. And its variable is d. Now notice distance is a scalar, so it has no arrow over it. Distance doesn't care about direction. It only cares about how long the path the object follows. Now, to look at these two things, on the left, distance and displacement. So here we have an object that started, we're going to say it started at 0 because that's easy, and it went 70 meters east and then 30 meters west. So its total distance, it traveled 70 meters, turned around and went 30 meters. Remember, distance doesn't care about direction, so the total distance traveled, 100 meters. Now on a scalar, distance is a scalar, on a scalar there will never be a positive or a negative. It's just a total traveled. Displacement, on the other hand, so the object started at 0 and it ended up at 40 meters. So the final position is 40 minus the initial position 0 to give a total displacement of positive 40 meters. Now because this is a vector, we always want to put a direction on it, and we've got a Cartesian plane here, went in the positive x direction, so positive 40 meters. We could also say 40 meters to the east is its displacement. Moving over to the example on the right, I got a person started at 30 meters and walked to 10 meters. So the distance that person traveled, altogether 20 meters, they didn't turn around. So the distance is almost the same as the displacement. The important thing about the displacement, though, is that it gets this negative. The person's position decreased, therefore its displacement is negative. So we're going to say this person traveled 20 meters in the negative direction, or this person traveled 20 meters west, depending on what we're talking about. Speed and velocity. Speed is the rate at which distance is changing. Anytime we talk about a rate, rate means divide by time. So speed is distance divided by time. Speed is a scalar. We don't care about the direction when we're talking about speed. Speed is a scalar because distance is a scalar and time is a scalar, because we can't make time go backwards yet. We represent speed by s. So s equals d over t. We've seen that before. Maybe you've seen r equals d over t for rate equals distance divided by time. Here we're going to call it s. S equals d over t. Distance divided by time. Velocity is the rate at which displacement is changing. So velocity is a vector because displacement is a vector. And since it's a rate, we divide by time. Rate means divide by time. So we take the displacement, divide it by the time. It's a vector quantity because displacement is a vector. And negative velocity means that the motion is in the negative direction, however we define that. Positive velocity means motion in the positive direction, however we define that. Using a number line is probably where we're going to start. And we represent velocity by a v with an arrow over it. It's a vector. We care about the direction. So to recap, we need to know the difference between a scalar and a vector. Vectors care about direction. We've got distance, which is the total length of the path. We've got displacement, which is how far an object is from where it started, as well as the direction that it traveled. Speed, rate at which distance is changing. Since distance is a scalar, speed is a scalar. Velocity is the rate at which displacement is changing. Because it's rate, we divide the displacement by time, and it's a vector because displacement is a vector. Velocity cares about direction, speed does not. I think that's it for my first video. I hope you enjoyed it. I will get better at doing this as we go, and I will see you in class. Thanks.